Welcome back, my 7th grade advanced students. We'll be learning lesson 5-3 today. Use linear models to make predictions. The first one, discuss and solve it. It says, Bo has a new tracking device that he wears when he exercises. It sends data to his computer. How can Bo determine how long he should exercise each day if he wants to burn 5,000 calories per week? We see the data over here on the graph. So the first thing we're going to do is draw a trend line to the lower points for 30 and 60 minutes. 30 minutes would be here at about 250. 60 minutes would be here at about 500. And we're also going to do it at 90 minutes. At 90 minutes, it looks like it's sitting about 775, somewhere around there. All right. There is a balance of points above the trend line at 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. So about 7 above and 7 below. Sitting pretty close to the middle. This shows me that there'll be 250 calories burned at 30 minutes, 500 calories burned approximately at 60 minutes. 500 calories times 10 is 5,000 calories. Remember, we're trying to find how long he should exercise each day if he wants to burn 5,000 calories. All right? And so we're going to go ahead and multiply 500 times 10 because we know that 500 times 10 is 5,000. So it would take 10 hours to burn 5,000 calories at this rate. Suppose another set of data were plotted with the trend line passing through 25, 100, and 80 and 550. Would this indicate that more or fewer calories were burned per minute? They want us to explain. Well, again, we're going to put our coordinates there, 25 and 100, and 80 and 550. And this would indicate the two coordinates that we were told to use for the trend line. Now I'm going to make my trend line through there. I'm going to show you my original trend line that was here before. So we're saying, would this indicate more or fewer calories burned per minute than the original one? Well, you might think just by looking at it being beneath it, it's going to be less. Not necessarily true. Remember, they're asking how many more calories were burned per minute. So it really depends on the slope of the line. At first glance, they appear to be parallel with each other. But when we use the coordinates that the trend line resides on, with our slope formula, we notice a difference. So we're going to use these coordinates here. The original coordinates for this line were 25 and 200, and 80 and 700. We take our y2 minus y1 over x2 minus x1. That's going to give us 500 over 55. And 500 divided by 55 is 9.09 repeating. Next, we're going to use the new coordinates. And the new coordinates we're using up here, 25 and 100, 80 and 550. When we use the slope formula, y2 minus y1 and x2 minus x1, we get 550 minus 100. That'll be 450. And 80 minus 25, that's 55. And 450 divided by 55 is 8.18. This would mean that fewer calories were burned per minute. The second line is not as steep as the first line, so fewer calories are burned per minute. We know that the steepness is what matters when it comes to the calories being burned. And we can see the original coordinates, that original trend line is steeper than the second one. Example 1, it says, use the slope to make a prediction. This example, it says that Michaela is a speed skater and hopes to compete in future Olympic Games. She researches the winning times of the past 50 years. If the trend in faster speed continues at the same rate, how can she use this information to predict what might be the time to beat in 2026? And remember, this indicates the years after 1960. So that would mean my y at 0, 0 here is 1960. So 10 years later would be 1970, 1980, 1990, 2000, 2020, 2025, which would make 2026 about right here. All right. By using this, it'd be pretty hard to narrow down because we're talking about winning times per minutes. I know it's going to be somewhere between 1.6 and 1. I think 8, right? It's going to be about somewhere in here. Let's find out. First of all, I'm going to draw a line for my trend line. And then I'm going to write an equation for it. I know that my y-intercept is 2.4, so that's going to be at the end of my equation. I also know that the slope is going to be, I can use these 2 points here. It went down, well, if this is 2.4 and this is 2.0, this must be 2.2. So that means every one of these units is 0.2, right? And then every one of these across is 10. So that would make another one of these, let's see, this would be 5, 10, 15. So we got 0.2 over 15. That equals, remember, this is a negative slope. It's going down. So this is a negative 0.2 over 15. And that's going to be about negative 0.0133. Now we got our formula. Y equals negative 0.0133x plus 2.4. Next, we're going to use the equation of the trend line to predict what might be the winning time in 2026. All right, remember, right now, we're looking for 2026. We have data all the way from 1960. So I'm going to take 2026 and subtract 1960 from it. That gives me 66 years. Now, remember the formula for this equation was y equals negative 0.0133x plus 2.4. I'm going to go ahead and replace x with 66 since it's 66 years, and x indicates the number of years that have gone by. When I multiply 0.0133 times 66, I get 0.8778. When I add that number to 2.4, I get 1.5222. That means if the trend in faster time continues at the same rate, Michaela should target about 1.5222 minutes, or That would be about 1 minute and 30 seconds. All right, assuming the trend line and the graph continues, use the equation of the trend line to predict average fuel consumption in miles per gallon in 2025. The equation of the trend line is y equals something x plus something. Well, I know that my y is going to be between here and here, and it looks like, let's see, between 12 and 18, that's a difference of 6, so every one of these must be 3. The difference between 18 and 24 is also 6. So that definitely means that every one of these is 3, and 12 plus 3 is 15. So this must be 15. Now I know I go up, let's see, I'm going up 3, because every one of these is 3, and then I'm going over 10. So that would make my slope 3 over 10, and that would make my y-intercept 15. All right, so now the average fuel consumption is predicted to be about what? Well, remember, we want 2025. This is the years after 1980. So this would be 1990, 2000, 2010, 2020, 2025. That's about 45 years. So now I have to take 45 and multiply it to 3. When I do that, I'm going to get, let's see, 45 times 3. That's going to give us, here, the 135. And then we have to add that to 15. So that's going to give us 150. All right. So we can predict to consume about 150. The average fuel consumption is predicted to be 150 miles per gallon. Is that right? Let's see. Oh, I'm sorry. Is this? Yeah, this is 115. Oh, I'm sorry. I didn't divide by 10. I have to go ahead and correct this. Glad I caught it before I continued. So when I divide this by 10, that's going to bring the decimal point over. So that'd be 13.5. Okay. So let's see, 13.5. And then when I add 15, it should give me about 28.5. So when I check my answer, I should get 28.5. All right. Next it says, why can you use a linear model to predict the y value for any given x value? Okay. So if I use the linear model, the slope in the linear model tells you how much the y value changes for each unit change in the x value. All right, next we're going to example 2. Use a scatter plot to make a prediction. The scatter plot shows the relationship between the number of people at a water park and the temperature. So about how many people should the owners of the park expect at the water park when the outside temperature is 90 degrees? which shows here when the temperature is 90 degrees, you're going to have about 800 people here. We find the value for x value of 90. You can approximate since the y value, since it is an estimate, and we did say 90 would equal about 800. The park owner should expect about 800 people at the water park when the outside temperature is 90 degrees. All right, now we're going to interpret the slope and y-intercept. The scatter plot at the right suggests a linear relationship between the temperature and the number of smoothies purchased in thousands. What does the rate of change or slope represent in this situation? Well, the rate of change or slope describes the number of smoothies purchased for each degree of temperature that increases. What does the y-intercept of the line represent in this situation? As you might guess, the y-intercept represents the number of smoothies sold when the temperature is 0 degrees Fahrenheit. Looks like when it's 0 degrees, there might be about 8 smoothies sold. What equation relates the temperature, which is x, and the number of people who buy the smoothies, which is y? Well, we're going to find the slope, so we need 2 points on the graph of the trend line, and we got 40 and 32, and we have 80 and 56. We know this is 56 because 40 and 64, well, let's see, there's a difference there of 16, right? And so when I add 8 to 48, I get, half of 16 is 8. And when I add 8 to 48, I get 56. So this must be 56. So when I use my slope formula, 56 minus 32, remember, we're taking the y from our bigger one and minusing the y from our smaller one over our x from our bigger one minus our x from our smaller one. We get 24 over 40, which is 3 over 5, because I can divide both of these by 8. 24 divided by 8 is 3. 40 divided by 8 is 5. Now I know my slope, and I know my y-intercept was 8, because as we said, each one of these units is 8. That gives me everything I know for my equation. Y equals 3/5 x plus 8. Remember, we're always writing a linear equation as y equals kx plus 8. All right, it says the Smoothie Cafe has an ingredient needed to make 50,000 smoothies on a day when the high temperature is expected to reach 90 degrees Fahrenheit. Should the cafe employees expect to have enough ingredients for the day's smoothie sales? Let's see. I think if they have enough ingredients, how can we make sure? Well, let's use the formula that we had in our previous problem. Y equals 3 over 5x plus 8. Since it's 90 degrees, and we remember that the temperature was x, I'm going to go back just to make sure. Yes, x was my temperature. Y was the thousands of smoothies that I made. So I'll replace x with 90. All right, now I know that I need to multiply 90 times 3/5. I'm going to multiply 90 times 3. That'll give me 270 for my numerator. And now I have to divide my numerator by my denominator. When I divide 270 by 5, I'm left with 54. Now I can add. I'll take 54 and add 8. That'll give me 62. You might think at the beginning this is just going to make 62 smoothies. But remember what our scale indicated. This was in thousands. So that would mean there are 62,000 people that are going to want smoothies. So according to the scatter plot, they should expect to sell 62,000 smoothies on a 90-degree day, which means no, they will not have enough ingredients, okay? Because they only have ingredients to make 50,000. All right, remember our key concept. Scatter plots can be used to make predictions about the current and future trends. Look for the corresponding Y value for the given value. Find the equation of the trend line and find the Y value of the given value. Basically, what we've already learned, create your equation and then replace your X value or Y value with whatever information they gave you. And then use your power of equations, your knowledge of equations and inverse operations to isolate the variable and find out what the missing variable is. All right, how do linear models help you to make predictions? The line shows a trend in the data. You can solve the equation to predict a likely outcome. Number two, how do you find the equation of a linear model when you're given the graph but not given the equation? You're going to use the slope formula and points on the graph of the line to find the slope. Then use the slope and the y-intercept to write the equation. Number three, can the linear model for a set of data that is presented in the scatter plot always be used to make a prediction about any x value? Explain. No. Sometimes the linear model will give you a negative number or an unrealistic number once you go outside of the range of the scatter plot's data. You might need to press pause to get all these notes down before you proceed. If you got it all down already, keep going. Number 4 says the graph shows a family's grocery expenses based on the number of children in the family. Makes sense. The more number of children you have, the more your grocery bill is going to be. Using the slope, predict the difference in the amount spent in groceries between a family with 5 children and a family with 2 children. They've given us the formula here, which makes it pretty easy. Since I know my formula is going to be y is equal to 21.08 x plus 85.15. I know I can replace x with the number of kids you're talking about. They want to know the difference, that's a subtraction problem, between a family of 5 and a family of 2. So that means first I'll have to find for the family of 5. I'll replace x with 5. When I do this, I'm going to have to take 21.08 and multiply it to 5. Eight times 5 is 40. That'll give me 0, so that'll put that 4 right back there. 1 times 5 is 5. And 2 times 5 is 10. I'll move my decimal 2 places. So that tells me it's $105.40. So this is going to be y equals $105.40 plus $85.15. I'm going to go ahead and put this underneath since we're adding to make it easier. I have to borrow 1 here for me to have 10 over here. 3 minus 1 is 2. 5 minus 5 is 0. 10 minus 8 is 2. That is $20.25. That's the difference. Oh, excuse me. That's, uh, I'm sorry. I was supposed to add that, not subtract. I totally botched that up. I'm going to have to go back and undo that. A little embarrassing, but better to figure it out now than never to figure it out and have you guys tell me I messed up, right? Right now, it doesn't want to leave pin. There we go. And if you caught it, and you were screaming at Mr. Metters, you're supposed to be adding. Good on you. So let's see, this would have been 0 plus 5, which is 5. This would have been 4 plus 1, which is 5. It's been 5 plus 5, which is 0. Carry the 1. Would have made this 9. That would have equaled $190.55 for a family of 5. Okay, so that's one coordinate. But we're concerned with the amount. So now we have to figure out how much is a family of 2. I'm going to use the same equation, but this time I'm going to put y equals 21.08 times 2 instead of 5. It's just 2 children in the family. You might be thinking, why are they adding this amount here? Remember, this is the number of children. The 2 adults have to eat too, right? So whatever adults are there are gobbling up $85.15, obviously. All right, so let's continue. This is going to be a little easier. 2 times 8 is 16. We'll carry the 1. And that'll be 16 comes down. I know 2 times 1 will be 2. I know 2 times 2 will be 4. Now I have to add $42.16 to $85.15. Let's hope I don't start subtracting again. 6 plus 5 is going to be 11. Carry the 1. This would be 3. 2 plus 5 will be 7. And 4 plus 8 will be 12. So a family of 2 will use $127.31. So now we're going to take the family of 5s, 190.55. We're going to subtract, remember we want the difference of 127.31. This should give me 5 minus 1 is 4. 5 minus 3 is 2. I have to borrow 1. 10 minus 7, it was a 7, right? Yes. That's 3. And 8 minus 2 is 6. Looks to be about a $63.24 difference in the two prices here. Okay, and I think this could have been a lot easier when you think about it, because if this is the number of children, then this here represents how much it needs to feed one child. We could have just multiplied this number by 3 and got the same number. Okay, but I did show you using the equation like they wanted you to. You're probably thinking now, thanks a lot, Mr. Mendes. That would have been a lot easier. But as I said, I'm trying to show you the way they want you to. So the answer to this one would have been $63.24. All right, how many children can you predict a family has if the amount spent is on groceries is $169.47? This is kind of working things backwards, actually. I'm going to need some space, so I'm going to get my eraser here and get rid of some of this. And it's really not that difficult, to be honest with you. All right, so now we're going to make the equation, but we're going to show what y is, because we already know the amount. So we're going to have 169.47. That has to equal, remember our equation, 21.08, 21.08 x plus 85.15. To solve this, we solve it just like a two-step equation. We're going to minus 85, 15 from both sides, because I need to get x by itself, right? X is being multiplied to this. I'm going to use PEMDAS backwards. I have to solve my addition first. And since these are both constants, they are like terms, I can combine those. So now I'm going to subtract $85.15 from this side. 7 minus 5 is going to give me 2. 4 minus 1 is going to give me 3. 9 minus 5 is 4. And 16 minus 8 is 8. So now I have $84.32 equals $21.08 times x. Now, much like before, what we learned, to get x by itself, I'll need to divide this by 21.08. Whatever I divide from one side, I divide from the other. X is left over here by itself, and now I have to solve what is 84.32 divided by 21.08. I'm going to need some more room to solve this division problem. So I think I'm going to use this area over here. Okay, we've got 84.15. And we're going to divide that by 21.08. I know that 21 can go into 48 4 times, but I don't think 0.08 will go into 15 4 times. So I think we're going to have to go with Let's find out. I don't see it happening, to be honest with you. Um, let's see. Oh, I'm sorry. This should be 32. I put the wrong number down. It should have been 8432 divided by 2108. I don't know why I put that one over there. And now it makes more sense. I can multiply this by 4. 8 times 4 is 32. 1 times 4 is 4. And 2 times 4 is 8. Which tells me that $169.47 can feed 4 families, 4 children. All right. I'm sorry, I said 4 families before. 4 children. Remember what our number line represents. 4 children. All right. I think that's all the ones that I have for you today. Yours is the practice and problem solving. Go for it, and I will see you when I get back. Hold on to your homeworks. We'll grade them when I return. Thank you.